Some of you don't giving me the permission to record. Please give me the permission. Yes, thank you very much. All right, guys. So let's start. Yes, please. Anything wrong? All right, guys. So last class we have started propositional logic. We give brief introduction. What is propositional logic? We're talking about proposition and statement. Then we talk about primitive statements. Then finally we have talked about connectives. So connectives is the way of joining two and more primitive statements. Then we have talked about truth values and truth tables, and we have seen these 5 connectives, truth tables. So what are the connectives we have studied so far? So first one is like V. It is called disjunction or. Then we have talked about inverted V, which is nothing but conjunction or and. Then we have studied not. Then we have studied implies. Then finally we have studied bidirectionals. Okay, guys. Now this is the truth. This is the truth values of all the 5 connectives. Now, today we will study more about a very important connective which is called implies. If P and Q are primitive statement, then can you tell me what is the truth value for P implies Q? 0, 0, what should be it? Recall your memory.
Sir, 1.
Sir, true.
Okay.
1, sir.
0, 1, what should be it?
1, sir.
So last day I had some problem with the network. I couldn't
1,
attend this.
0,
0, sir.
0, and 1, 1.
Sir, 1.
1.
Achha. Now, what is the plain English meaning of implies? That is the question. It means if P then Q, or P if only Q, or P is sufficient for Q, or Q is necessary for P. So these all are same representation in plain English. Please remember, whenever we use sufficient, then P is first, Q is next. But when you use necessary, this Q becomes first and P becomes last. This is nothing but actually kind of language structure. But the original thing is P implies Q. Now, what is P implies Q? What does this truth table says? So let's take an example. Let's take Nishat. Nishat is one of my students in this class. Am I right, Nishat? Nishat?
Yes, sir. Yes, sir.
Okay, we are going to experiment with you. Okay?
Okay, sir.
So let's assume P is the statement Nishat gets less than 60 in NEET. Okay, what is Q? Nishad
Is not doesn't get
will study more than 4 hours. Discrete DM NEET. Discrete Math. Okay, so P is this primitive statement. Nishad gets less than 60 in discrete mathematics NEET. And what is Q? Nishad will study more than 4 hours daily. Okay, guys. Now, now, any one of you tell me what P implies Q means. In plain English, what is the meaning of this? If P is Nishad gets less than 16 discrete mathematics and Q is Nishad will study more than 4 hours in daily, then what is this?
If Nishad gets less than 60 in DM mid, then Nishad will study more than 4 hours daily.
Fantastic, fantastic. If Nishad gets
Sir, can you move the camera towards left?
what happened to camera?
Can you move the paper towards right, or can you move the camera towards the left? We can't see it.
Okay.
Yeah.
Okay. Now let's go to truth table. That is the fun. Truth table is the fun. So what is the first entry in the implies truth table? If P is 0 and Q is 0, P implies Q equal to 1. Okay? So what is the meaning of this? Tell me. What is the meaning of this? That means if this statement is 0, then this statement is also 0, then altogether this is true. What is the meaning of this?
If Nishad doesn't get less than 60, then she don't need to study more than 4
That
hours.
means Nishad gets more than 60 and Nishad will not study more than 4 hours. So is there anything breaking? Mane, does he break any resolution? What is her resolution actually? Her resolution is if I get less than 60, I will study more than 4 hours. It is her resolution. She is determined that somehow if I get less than 60, then only I'm going to study more than 4 hours. That is her resolution, determination. Now she get more than 60 and she did not study more than 4 hours. Does anything breaking here?
No, sir.
Nothing is breaking. All right. So that's why as this statement is not breaking, that's why it is this statement overall true. Is it clear to you guys?
Yes, sir.
Okay. Now,
Yes, sir.
Nishad gets less than 60 in discrete mathematics. And Nishad will study more than 4 hours daily. এটা ভালো মতো খেয়াল করেন। Nishad gets less than 60 in discrete mathematics, which is still false. We are going to second entry. 0, 1, 1. So Nishad gets less than 60 in discrete mathematics, 0. And Nishad will study more than 4 hours daily, that is 1. So what is the meaning of this?
That even if she gets more than 60, she will still study more than 4 hours.
Okay. So is there anything breaking or not?
Yeah, her plan
Yes,
is
sir.
breaking. Resolution is breaking.
No, sir.
out. Yes, it's breaking.
Some people are saying her determination is breaking, and some
Yeah.
people is saying
It is
actually the determination is not breaking. The people who says determination is breaking, how can you explain why it is
Sir,
breaking?
Sir,
because basically Nishad here her intention was if she gets less than 60, then she'll study more than 4 hours daily, or else she will not. But here
Or else, wait. Why did you get or else?
sir, like according to this statement, if she gets less than 60, then
The
she will
problem
study
is,
more.
guys, the problem is the way you people are taking implies. You are actually taking the meaning of implies in daily English. We have already given you an example. What is that example? That example is the way we use or in daily English. That is not actually or in logic. That is actually exclusive or. You people taking implies in such a way that is actually bidirectional. That is not implies. If it is true, then it must be true. If it is false, it must be false. The thing you are taking, else, you added the part else. That way you are actually talking about bidirectional in logic, not implies.
Okay, sir. I didn't know about
Did you get it?
bidirectional.
But it is not bidirectional, it is implies. So now listen to those guys who says it is all right. Tell me why it is all right.
স্যার এই স্টেটমেন্টে বলা নাই যে সে 60 বেশি পাইলে কি করবে।
You
সে বলছে-
wonderful. Listen, এটা বলা নাই, এটা implies is one way directional. The direction is one way. That direction is only says that if we get less than 60, what she is going to do? If we get less than 60, that means if the first statement is true, P is true, then what should be the status of the queue? That is only saying. It never says if the first statement P is false, then what is Q? Wonderful. So then
sir, does implies work like a diode one way?
it's a work like a diode, one way. Yes. That's why the symbol is also implies one way. True, very true.
Okay, so thanks.
Then, so what is the meaning of this? Nishad gets less than 16 discrete mathematics. Meet 0. Then Nishad will study more than 4 hours daily. 1. So she did not get less than 60. She might get 61, 62, but still she thinks it is not well enough. So that's why she is studying more than 4 hours. Still, it might be 1. All right, guys, did you get the point?
Clear, sir.
Yes,
Yes,
because
sir.
she did not break
Yes,
the
sir.
resolution. Her resolution is only breaking if she gets less than 60 and if she did not study. Then only the resolution will be breaking. Right? So let's go back over here. When P is 1, Q equal to 0, then P implies Q equal to 0. So if it is 1, it is 0. Then the whole thing is 0. It means Nishad gets less than 16 discrete mathematics bit. True. Still, Nishad is not studying more than 4 hours. She is completely breaking the resolution. That's why it is false. Did you get it?
Yes, sir.
Yes, sir.
Yes, sir. And last one is actually P is 1, Q equal to 1, P implies Q equal to 1. So
Yes.
it is true, and she did not break her resolution, so of course it is 1. So she get less than 60 and she is studying more than 4 hours. Both are true, so resolution becomes true. 1. So we are done. Okay. Okay, I'm going to give you another example.
Yes, sir.
Yes, sir.
If Bobby does not finish homework, his parents will not accept it positively. If Bobby finishes homework, his parents let him watch it. Is it clear to you? Example is clear to you. So what type of expression is this? Let's assume Bobby finishes homework. It is the primitive statement P, and his parents let him watch cricket match. This is actually Q. Then what is this statement?
If P is true, Q is true.
No, we are not talking about truth table. What is the statement? What is the proposition? Compound statement.
Boundary.
Huh?
So if Bobby finishes his homework, then his parents let him watch.
Yes.
a
What
cricket
is the proposition?
Compound, sir. Compound, sir.
Compound. Yeah, it is a compound. What is the
Yes, sir.
expression?
Primitive দুটা মিলায় compound.
What is the expression?
Implies.
Implies. P
Oh,
implies Q.
implies. Oh, so P implies Q. Sir.
Implies.
Sir, I was not getting what you were asking. Sorry.
Okay. P implies Q.
Yeah, sir.
Now, what is the actual meaning of this? In daily English, what is the meaning of this? It means if Bobby finishes homework, then his parents will let him watch actually the cricket match. If Bobby does not finish homework, then his parents does not let him watching cricket match. That is the daily English, right? That means when P equal to 0, then Q must be 0, then P implies Q equal to 1, and when P equal to 1, Q equal to 1, P implies Q is 1. Otherwise, like 0, 1, it is actually 0, 1, 0, it is actually 0. But in daily English, this is the truth table for this statement. But unfortunately, this is not implies truth table. Am I right?
Yes, sir. It's not.
What is the truth table?
Yes,
What
sir.
is this truth table?
If Bobby finishes homework,
What is this truth table?
this is bidirectional.
This is bidirectional. So actually, whenever we use implies in daily English, we are actually using bidirectional, not implies. So that is the problem. So you people would be very careful. Daily English and the logic, there is a difference. So please remember, whenever we use implies in daily English, we always use the bidirectional, not the implies. On the other hand, what is the truth table for this? What is the truth table for this?
For P implies Q, it should be
0, 0,
0, 0,
1,
1.
1,
0,
1,
1,
1, 0, 0, 1, 1,
1, 0,
1, 0, 0, and 1
সেটা 0 হবে না? হ্যাঁ।
Okay. So the statement only broken away only when Bobby finishes his homework. Bobby finishes his homework. Still, his parents does not allow him to watch cricket match. Then only it is broken. Am I right?
Yes,
That
sir.
means P is true. Bobby finishes his homework. Still, his parents are very mean. They are rude. They are not kind enough. They don't let him watching the cricket match. Only then the resolution is broken, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
That's why when it is 1, it is 0. That time the whole thing is 0. You might argue, sir, this is
Sure.
a little bit confusing. If Bobby does not
Yeah.
finish homework, then why his parents are let him watch
It's not
cricket
said
match?
here.
Because it is implies. Because it is implies. It does not say anything about that one. It is talking about only the reward. It does
Yeah.
not talk about any kind of punishment. Okay, it is all about reward. It's a positive sentence. It is a reward. That's why, uh, as it does not say anything about this, that's why it is always considered true. All right, guys, did you get it?
So can you say the last
This is
part?
all about
Yes.
positive thing.
Yes, sir.
Because no punishment is mentioned in this sentence, only the reward is mentioned. And when the reward resolution broken, he finishes, he does his job. Still his parents are mean, they do not allow him to watch cricket match. That time only the resolution is broken or the determination is broken. That time only the statement is false. Other times, as it does not mention about any kind of punishment, it is also considered. All right, guys, do you have any question? You can ask me.
No, sir.
Okay. If you have no question, can you tell me? Let's see two important things.
Sir, the screen is really blurry here. Like,
I can do
Yes, sir.
anything about that one. It is because of the bandwidth. I cannot do anything. Is it still blurry?
yes,
Yes,
sir.
sir.
Yes,
Like,
sir.
Completely.
Yes, sir.
Actually, I cannot do anything about that one because it is because of the uh, bandwidth. Is it clear now?
No, sir.
A little
No, sir,
bit.
not yet. Now,
sir,
It's
I
working.
guess
Sir.
I guess it would be better like if you can like write in it with a bigger font. Like
write
then,
my bigger part.
yes, sir. If you can use bigger font to write them, then the blurriness would not matter that much, I guess.
Bigger what? I don't get you.
Bigger font, bigger font.
Sir, he means you know,
So he meant you just write in a like letters in a bigger
Okay,
way.
okay, bigger way. Okay, okay. Okay, let's
স্যার
go.
স্যার সরি স্যার টু ইন্টারাপ্ট বাট আপনার এই যে ওয়েব ক্যামেরার দিকে অনেক ব্লারি আর আপনি যদি বিগার ফন্টে এমনিও লিখেন এটা পিক্সেলেটেড আরো বাজে রকম আসবে আর দেখতে বোঝা যাচ্ছে না ওইটাই বলতে যাচ্ছে ওরা
ওটা because of the bandwidth.
sir clear হয়ে গেছে স্যার
Okay, clear আছে তাহলে আবার start.
Yes, sir. It's clear now.
Okay. All right. Okay. Can you tell me the truth if so if P and Q are primitive statement, we're trying to find out the truth table of P implies Q bidirectional, not P or Q. So please, you people will tell me. So P, Q, P implies Q, not P or Q, and finally P implies Q, bidirection, not P or Q. Okay, guys? All right. Let's write down all the input pattern. 0, 0, 0, 1, 1, 0, 1, 1. What is this?
1, sir.
1,
Okay. What is this?
1.
0,
1.
0, sir, 1.
Why you are saying 0?
Sir, আগেরটার হিসাবে বলছিলাম 1,
1, 0?
0.
1.
0, sir.
No, আগেরটা হিসেবে কি? আগে কোথায় 0 লিখেছি?
No, sir, I thought about that was the first example. Sir.
Don't thought. Okay. So 1, 0.
0.
Okay. 1, 1.
1.
How about this?
Not P, which means 1.
0 becomes 1.
0.
1.
1, sir.
0 becomes
1. 1.
this 0 becomes
1.
1 and Q is 0. So
1.
1
1.
or 0, it is 1. Then how about
1.
this?
1.
1, sir.
This
1, 1, 1.
0 becomes 1, Q is
1.
1, so 1. How about this?
0.
This
0.
becomes 0,
Zero.
so 0.
Last one is 1.
1,
Last one is 1.
1.
Then what is the truth value for this, the final one?
Bidirectional. So
1, 1, 1.
Sir, all
One,
1, sir.
all of them
One.
are 1. All of them are
1,
1.
1, 1.
1,
0 becomes 1
1,
and 1, 1.
1.
So what is the specialty about this?
All are true.
All are true. No matter which input pattern you are giving, always the output is true. These are called what? Do you know the name of this? What are those called? And the
No,
output
sir.
is always 1. It's called tautology. Tautology. Denoted by T0. What is it called?
Tautology.
Tautology.
Tautology. Tautology means always true. It is always true. Always true. That's why it is called tautology. Okay. Now let's go to another example. If E and Q are primitive statements, okay, we're trying to find out P and not P, whole bracket, and Q truth table. So
All
this
of
is
them will
P,
be
this is Q, not P. So what is the input pattern? 0, 0, 0, 1, 1, 0,
1. 1.
1, 1. So what is this?
1 1 0 0.
1 1 0 0. Then what is the value of this?
All of them 1. Tautology.
All of them 1. Can you recheck?
All of them 0, I think.
Why don't you say one by one? So here Q is 0. So it is with AND.
And
Oh,
So it
it's,
would be
it's
0.
and. My bad. Sorry.
Okay. Then
All-
here P is 0. So whole thing would be 0. Then the whole thing would become 0.
0.
Here Q is 0. So again it is 0. And here dot P is 0. So this becomes 0. So it becomes 0. So what is the specialty about this?
all are false.
All are false. So these kind of things are called contradiction. Or F naught. Always false. All right, guys. Done?
Yes, sir.
Now let's go to next topic. So, like algebra and arithmetic, you know what is algebra? What is algebra? What is algebra?
So mathematics with variables.
Mathematics with variables and other stuffs. Okay. Then what is arithmetic? Mathematics of numbers. The same way, propositional logic is called algebra of propositions. Okay. Because here, instead of dealing with variables or numbers, we are dealing with propositions or statement. Okay. So there is a very similarity between arithmetic, algebra, and logic. It is also like any other mathematical branch. So we are going to talk about logical equivalence. We are going to talking about logical equivalence. When you can say two integers are same, can you say four and 4, they are equal? How can you prove that?
By a sign, by a equal sign.
Huh?
Like, how can we show this or what? I didn't get
How
the
can you
question.
find that 4 equal to 4?
With an
Because,
equal sign.
no, by subtracting 4
Yes,
from 4 and
but
only 0 will be left.
okay, let's talk about x, y. Sometimes x is 4, sometimes y is 4, sometimes x is some different value like 5, y equal to 4. So when x equal to 5 and y equal to 4, that time they are
It's
not
not
equal.
0.
But
Yeah.
when x equal to 4 and y equal to 4, that time they are equal. So how can you check this, that x
X
and y
minus,
are equal?
when x minus y is equal to 0.
X minus y equal to 0. Okay, that is one procedure. That is correct. Is there any other procedure?
X divided by y will be 1. And y divided by x will be 1 too.
Okay, that is also procedure. Fantastic. So if I x minus y, we are checking x minus y equal to 0, then we are pretty sure they are equal.
Yes, sir.
Okay. Now, how can you verify two triangles are congruent? You know what is congruent, right?
Two sides
How can
equal.
you,
Two sides equal, two angles equal. Isn't it, sir?
so how can you verify two triangles are congruent? So let's assume I have a triangle ABC. I have another triangle DEF. They are congruent. How can you prove that?
So it's proving two sides or two angles of both of the.
Okay, so basic thing is I'm going to show this angle is equal to this angle. This angle is equal to this angle. The remaining angle is equal to remaining angle. Sorry, this side equal to this side.
Yeah.
Corresponding side of AB is equal to corresponding side of DE. Corresponding side BC equal to corresponding side EF, and corresponding side AC equal to corresponding side DF. So this might be one procedure, right? So there are many other way we can
Yeah.
also prove it is coming. How can you prove? Let's assume P. Now this is the $1,000,000 question. P and Q are compound statement.
When there are two different informations given.
P, listen carefully. After listening, answer the question. P and Q are two compound statements. How can you say they are equivalent? Now tell me the answer. How can you say P and Q are two compound statements? How can you say they are equivalent? Now tell me. When two compound statements become equal?
If the truth tables get same,
Wonderful. Then actually these two are nothing
Yeah.
but expressing the same thing, because always they are producing the same output for the same input. So they are actually equivalent. Did you get the point? Other people's
Sir,
same.
can you repeat again this question?
Yes, sir. Yes, sir.
How can you say two compound statements are equivalent? How can you prove that? Is the question clear to you?
Yeah.
How can you say
Oh, I got
two
it.
compound statements P and Q are equivalent? How can you prove that?
Truth
Yeah,
table.
if the truth table
If
is the same, they have the same values.
if both compound statements truth table are same, that means for same input they are producing the same output, then only actually they are equivalent. Am I right or not?
Yes, sir.
Because they are functionally same. For same input they are showing the same output, so they are functionally same. That time we will say they are equivalent. Did you get it or not?
Yes, sir.
Yes, sir. Thank you.
Okay, then give you an example. Now see, P, Q, P implies Q, not P or Q. 0, 0, 0, 1, 1, 0, 1, 1. What is the truth value for this? 1. This one is 1. This one is what? What is the truth value for this?
Sir, 0.
0.
0,
This one is
1.
1. How about this?
This one
What is the
is
truth?
sir, 1.
1 is
1,
1.
sir.
1.
How about this?
1, sir.
This is also
1.
1. How about this?
0.
0.
0.
How about this?
1.
0.
1.
So what is,
Oh, sorry, 1.
if you compare both of this, same truth table, right? So what is the meaning? P implies Q. They
They are
are
equivalent.
functionally same. So we can write P implies Q. Sometimes they use this one, 3 bar. Sometimes they use this one. Okay, I prefer using this one. Do you have any question? You can ask.
No, sir.
Okay, guys, do you have any question?
No, sir.
So this is called the equivalence. Acha, can you tell me what it means? What is the meaning of this actually, this symbol? When, tell me, when two compound statements truth values are same, that means 1 against 1, 1 against 1, 0 against 0, 1 against 1, then what is the truth table for this?
Biconditional.
দেখে নিয়ে আগে এই বাই ডাইরেকশনের ট্রুথ টেবিলটা কি হবে?
All one.
One,
All ones.
all one. So what is this? This is nothing but
Tautology.
tautology. So another meaning of this is P implies Q, bidirection, not P or Q is a tautology. It is also another meaning of this. Okay, guys? All right. Do you have any question? No question, sir?
No, sir, not yet.
No, sir. Clear, sir.
Clear. Okay. Now, many things which are actually present in algebra and arithmetic, those kind of similar logical expressions are also present in logic. For example, let's write this one. A star B plus C, where A, B, C are real numbers. If this is the case, what can we write?
AB plus AC.
A star B plus A star
Star C.
C. What is it called? What type of rule is this?
Law of distribution.
Law of distribution. Law of distribution. Star over plus. So this is a arithmetic law. But if we flipped star and plus, is it also true? If we write A plus B star C, what is this? Is it actually A plus B star A plus C? Is it true?
No.
No, sir, because A is square Asha, so it is not true. Okay? But if P and Q are PQ and R primitive statements, then P or Q and R is logical equivalent to P what type of law is this? This is also distribution, right? No?
Distribution, yes.
Law of distribution. But এখানে দেখা যাচ্ছে in the logic there is two distribution law. There is two distribution law. Where in arithmetic there is only one distribution law. If you make an analogy start with actually this and plus with that, then in logic both way distribution might be possible. But arithmetic there is only one way distribution for the operator plus and star. Is it clear to you? So logic might have more. Okay. So how can you prove this? How can you prove this kind of formulas? How can you prove this kind of formulas?
With truth table.
Truth table. Using truth table, you can prove this kind of formulas. Now I'm going to write a complete list of logical equivalence formulas. Okay. And if you want, I'm going to prove one or two formulas if you want. Okay. So let's write down the formula table.
Sir, 1 minute, sir. Let me.
Yes, it is. Tell me. What is wrong?
Sir, just 1 minute, sir. I have to note it down just.
Oh, please, go ahead. Please. Yes.
স্যার এখানে যে দ্য ল অফ ডিস্ট্রিবিউশনে আপনি সেকেন্ডটা লিখছেন লাইক
হ্যাঁ।
এখানে হচ্ছে এন্ড হবে না
কোথায় end হবে?
অর দিছেন এন্ড হবে না
কোন লাইনে এখানে?
জি স্যার লাস্টের ওয়ার্ডটাতে লাইক আপনি একদম
ও হ্যাঁ থ্যাংক ইউ হ্যাঁ এটা ঠিক বলেছেন থ্যাংক ইউ ভেরি মাচ থ্যাংক ইউ মাই স্টুডেন্টস আর ভেরি কেয়ারফুল থ্যাংক ইউ কে হু ইজ দিস মহসিনা তাবাসসুম
স্যার নূরে জান্নাত দিশা
Nure Janat Disha, thank you very much. You are right. Thank you. Sometimes I made mistake. Thank you. Is it clear? It should be and because the whole thing is distributed. Yes. Done?
Done, sir.
Should we continue?
Yes, sir.
Okay, sir.
স্যার
হ্যাঁ
আমাদের প্রিভিয়াস ক্লাসের নোটস আমরা কখন পাবো স্যার?
পেয়ে যাবে এই যে আমি আজকে ক্লাসটা নিয়ে সবকিছু গুছিয়ে ফেলবো and I'm also going to upload the videos. Don't worry.
But it's blurry again. We can't understand that.
Blurry again?
Yes, sir, I think. It's আমার এখানে স্যার একটু
it got blurry sir.
What is blurry?
স্যার আপনার নেটওয়ার্কটা একটু উইক আছে এজন্য।
I don't think my network is weak. My network is very fast. There's nothing blurry in my.
Sir, I think your network is like fluctuating a bit because every one of us is seeing it blurry.
No, it is because of actually the Google bandwidth. Now a lot of people are using the Google Classroom bandwidth from IOB. That's why they reduce my bandwidth. I don't think my bandwidth is.
Sir,
it's fine now.
It's fine
It's
now.
fine now.
Yeah.
Because my one is very fast now. I can even run HD videos. So should we continue?
Yes, sir.
Okay. So first one. The law of double
স্যার
negation.
ক্যামেরাটা একটু লেফটে করা যায় লেফটে দেখা যাচ্ছে না
The law of double negation. The law of double negation. So what is the meaning of this? Double negation. P, এখানে লেখা দেন P, Q, R, R, primitive So what is the negation of P? Not P.
Not P.
What is the double negation of P?
Again P.
Not P. So what is the equivalence of this?
P, sir.
P. Number 2. The Morgans. So P or Q, not. What is this?
Not P and not Q.
Yes. So each of the primitive is going to be not, and each of the or is going to be and each of the and is going to be or. It has another part. What would be this?
Not
Each of
P
the
or not.
primitive statement is going to be not and would become or. Commutative. Commutative means we can actually change the order. So P or Q is nothing but Q or P. P and Q is nothing but Q and P. Number 4. Associative. Associative means who is connected with who, what? Who is connected with what? For example, P or Q or R. Now this Q is connected with R, and remember all the operators are same. If operators are different, then associative would not work. Then we have to use distribution. This is nothing but we associative Q with P now, if the operators are same. Did you get it? If the operators are same, we can associate.
Okay.
Is it clear to you?
Yes, sir.
If the operators, one of the operators are different, then we cannot associate. Then we have to distribute. And what would be this?
P and
P associate Q with P. C. Operators are same. That's how you can associate. If operators are different, we have to distribute. Distribution. What is this? We have already seen. What is this called? Distribution of over. The operators are different. That's how you distribute. Another form is there. What would be this? Distribution of idempotent. If two P are connected with OR, we can write only single P. If two P are connected with N, we can write single P. Idempotent. It's called idempotent. Then number 7. identity. P or F not, then what would be the answer?
P.
Yes.
और if not, yes sir, P হবে.
And P, what would,
This is also P.
It is P. Yeah.
then inverse. P or not P. What would be the answer?
Not P.
No. Why it would be not P?
P or
T naught. T naught.
P not হবে স্যার.
No.
P or not P. তাহলে
It would be always true. So it would be T not.
Exactly, sir. এটাই তো বললাম, T naught.
T not. And P and not P. What would be the answer?
F
It
naught.
is always false. F not.
S.
Then domination. Domination by the tautology and contradiction. P what would be the answer? P or T naught. It would be always T naught.
T naught.
And P and F naught. What would be the answer?
F
It should
naught.
be always F naught. Okay. Last one.
Sir, just a minute.
Please go ahead.
Done, sir.
Done. Absorption. P or P and Q. What would be the answer? P and P or Q. What would be the answer? P. Okay, guys, I'm going to prove one or two formulas. Which one you want me to prove?
First one.
Absorption. Should we try with absorption?
Okay,
Which
sir.
absorption one?
Just
First one or second
first
one?
one.
First one. Okay. P zero zero 01
Sir,
10
EQ হবে স্যার ওইখানে. তাই না?
কোথায় কি হবে?
স্যার সেকেন্ড কলামে উপরে
আর থার্ড কলামে যাবে P or Q.
এটা
এটা না।
প্রথমটা প্রমাণ করছে।
হ্যাঁ স্যার, লাইক
কোনটা?
প্রথম কলামে আপনি P লিখলেন, পরের কলামে তো Q আসার কথা।
ও আচ্ছা আচ্ছা, হ্যাঁ হ্যাঁ, থ্যাংক ইউ, হ্যাঁ হ্যাঁ, ইউ আর রাইট, ইউ আর রাইট। থ্যাংক ইউ। Q
P and Q,
P and Q
and then finally P or P and Q whole. Yeah.
Yes, thank you. 0, 0, 0, 1, 1, 0, 1, 1. Then this one is 0, this one is 0, this one is 0, this one is 1. And what is the answer of this?
0 0 1 1.
0, 0, 0. Second one is 0 and 0, 0. Third one is 1.
1
Fourth one is 1. Now see, this one and this one is same. So these two are equivalent. We are done. Last example. Tell me which one. Last example. Which one you want me to prove? Tell me. কোনটা? আপনাদের choice. Girls, you can say. Which one you want me to prove? The Morgans? The Morgans?
Yes, sir.
Okay. So the Morgans second part. Second one.
Yes, sir. The Morgan second.
0, 0, 0, 1, 1, 0, 1, 1. Okay, guys. So what is this? 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. What is this? 1, 1, 0, 0. What is this? 1, 0, 1, 0, 1, 0. What is this? 0 negation. 1, 1. This one is 1. This one is 0. And what is this? 1, 1, 1, 1, 0, 1, 0, 1, 1, 0. So see, same truth table. So all right, guys. Do you have any question? You can ask me. Done?
Yes, sir.
Do you have any question regarding today's class?
No, sir.
No, sir.
Everything
Okay, so I have given you a homework. The homework is you are trying to prove the law of the list of logical equivalence expression. You will take all the rest of the examples and try to prove whether they are actually true or not. Okay, guys?
Okay, sir.
Okay, see you. Have a nice weekend. See you in the next week. Till then, goodbye. Take
Thank
care.
you, sir.
Assalamu alaikum.
Assalamu alaikum.
Goodbye, sir.
Thank you. Alaikum assalam.
Assalamu alaikum.
Assalamu alaikum.